Good evening, children. Let us continue with the chapter 2, that is acids, bases and salts. Today we will be studying more about salts. So let's begin. We know that a salt is generally formed in the neutralization reaction, isn't it? When acids and bases react together, it forms a salt and water, right? And this salt is made up of two radicals. That is, one is positive radical and another one is negative radicals. Okay, positive radicals comes from the base and negative radicals comes from acid. For example, NaOH with HCl. NaOH is a base, isn't it? And HCl is a acid. So what happens now? Neutralization occurs. It forms salt, that is sodium chloride and water. So next, coming to the topic, family of salts, from where it is derived. Okay, NaCl, that is salt, belongs to two family. One is sodium salts family and chloride salts family. Okay, that is NaCl. What about CaCl2? That is calcium chloride. That comes from calcium hydroxide, that is calcium family, CaOH2, and hydrochloric acid, that is HCl, chloride family. So calcium chloride comes from calcium family and chloride family. Next is copper sulfate, that is CuSO4, comes from copper hydroxide. Okay, CuOH2, that is from copper salts family, and another one is sulfuric acid, that is sulfate salts family. Next is nature of salts. How do we get to know the pH of salts? So the pH of salt solution depends on the strength of the acid and bases from which it was formed. Okay, for example, a strong acid and a weak base. The pH of a salt will be acidic. So when there is a strong acid and strong base, it forms a neutral. So pH of salt will be neutral. And weak acid, strong base, that means alkaline. For example, sodium acetate. So the pH is 7 to 8. Okay, and ammonium chloride. Solution pH is 6. What about sodium carbonate? It varies from 11 to 12. pH value varies from 11 to 12. Next is sodium chloride. It is 6 to 7. Sometimes it is neutral also. And boiled distilled water, it is 7, less than 7 or greater than 7. Okay. Next, what do you mean by double salts? So this formed by the union of two simple salts. When two simple salts come together, when they combine, that dissolved in water and that going to crystallize. Okay, for example, K2SO4.Al2SO4 3.24H2O, that is potash alum. So this is a combination of two simple salt. Okay, and next is Morse salts, FeSO4, that is iron ferrous sulfate dot NH4 2SO4 and 6H2O. Okay, dolomite, that is CaCO3, calcium carbonate, magnesium carbonate. So here two salts are combining together in the union of two simple salt, it forms a double salts. Okay, so next, coming to mixed salts. Salts that contain more than basic or acidic radical. So more than one. Okay, so salts that contain more than one basic or acidic radical, that is positive and negative radicals. If it is more, then it is said to be mixed salts. For example, sodium potassium carbonate. So Na positive, K positive, CO3 minus. Right? So here two positive radicals you can see. Okay, so NaKCO3, sodium potassium carbonate. Next is bleaching powder, CaOCl2. Okay, Cl is minus here, O minus, so two negative radicals. Okay. Next is complex salts. Name itself says it is complex. Salts which on dissociation gives one simple ion and one complex ion. When salts undergo dissociation, what do they give? They give one simple ion and one complex ion. For example, common salt, that is simple ion plus complex ion. So that is sodium argentocyanide, that is NaAgCN2. It can give simple ion and complex ion also. It can give Na, sodium, and also argentocyanide. Okay. Next is silver amino chloride, AgNH32Cl. So this is also going to give simple ion, that is AgNH32, and Cl, that is complex ion. Okay. Next is chemicals, that is from common salts. Okay, you have one more topic. So that is chemicals from common salt. So by now we have learned that salt formed by the combination of hydrochloric acid and sodium hydroxide solution, which is called as sodium chloride. So this is the salt that we use in the food. Okay, so seawater also contains many salts that dissolved in it. Okay, sodium chloride is separated from these salts. So deposits of solid salt are also found in several parts of the world. These large crystals are often brown due to impurities. So this is called rock salt. So beds of rock salt were formed when seas of bygone ages dried up. Rock salt is mined like a coal. So we have heard that Mahatma Gandhi's Dandi March. So we know about sodium chloride was so important symbol in the struggle of freedom, right? So here we will be studying about different salts, that is common salt, sodium hydroxide, bleaching powder, baking soda, and washing soda. So we know common salt, it is a raw material for chemicals. So the common salt obtained is an important raw material for various materials of daily use, such as sodium hydroxide, baking soda, washing soda, bleaching powder, and much more. Okay, we shall see their importance. Sodium hydroxide. Okay, sodium hydroxide, when electricity is passed through aqueous solution of sodium chloride called brine. So people have come across this, right? So it decomposes to form sodium hydroxide. So the process is called the chlor-alkali process because of the products formed from chlorine and alkali for sodium hydroxide. So we know this electrolysis process, right? So next is bleaching powder. We know about bleaching powder also. So we have already come to know that chlorine is produced during the electrolysis of aqueous solution chloride, that is brine. So this chlorine gas is used for the manufacture of bleaching powder. So the chlorine gas which is evolving, so it is going to be used as a bleaching powder. So that is produced by the action of chlorine on dry slaked lime, that is CaOH2. So bleaching powder is represented as CaOCl2. Okay, so actual question or composition is quite complex. Okay, what are the uses of bleaching powder? So for bleaching cotton and linen in the textile industry, we make use of this bleaching powder. Okay, for bleaching wood pulp in a paper factories, okay, so we use this. And for bleaching washed clothes in laundry, it is extensively used. Okay, and this bleaching powder as an oxidizing agent in many chemical industries, and to make drinking water free from germs also we use this bleaching powder. Next, coming to baking soda, we people know the function of this baking soda and how it is extensively used. Okay, so the baking soda is commonly used in the kitchen, right, for making tasty crispy bondas, bhajis and all, right? So sometimes it is added for faster cooking, so to ferment something batter kind of things. So we it has to like ferment fast, so we add this baking soda, right? And also the chemical name of the compound is sodium hydrogen carbonate. Okay, that is NaHCO3. It is produced using sodium chloride as one of the raw materials. Okay, And we also check the pH of sodium hydrogen carbonate in the activity 2.14. Okay, and just go through it. And uses of baking soda, we know that for making baking powder, we which is a mixture of baking soda, that is sodium hydrogen carbonate, and a mild edible acid such as tartaric acid. So when baking powder is heated or mixed in water, what happens? So we see that sodium salt of acid like carbon dioxide and also water is formed, right? So carbon dioxide is produced during the reaction, and we can make use as a bread or cake to rise, making them soft and spongy. If there is an increase of carbon dioxide gas, what happens? That leads to the fluffiness of the what do you say, duff. Okay, and sodium hydrogen carbonate is also an ingredient in antacids. We know about antacids, right? So being alkaline, it neutralizes excess acid in our stomach and provides relief. And it is also used in soda acid fire extinguisher. It is also used in the fire extinguisher. Next, coming to washing soda. So another chemical name that we can be obtained from sodium chloride is Na2CO3.10H2O, that is washing soda. So you have seen above that sodium carbonate can be obtained by heating baking soda. So recrystallization of sodium carbonate gives washing soda. So it is also a basic salt. Okay, and so uses of this washing soda is sodium carbonate is used in glass, soap, and also paper industry. It is used in the manufacture of sodium compounds such as borax. Okay, sodium carbonate can be used as a cleaning agent for domestic purpose. It is also used for removing permanent hardness of water. Okay, so these are all the uses that you need to go through in your textbook once again. Okay. So next, coming to, are crystals of salts really dry? So do you think the crystals of salts will be dry? So for this we have an activity to perform. So what we are going to do is we need to set up an experiment as shown in the picture. So we need to heat a few crystals of copper sulfate in a dry boiling tube. Okay, so what is the color of the copper sulfate after heating? So we need to find out that, and we need to see whether water droplets in the is found in a boiling tube. And we need to just think, so where does this come from? So for this we need to add 2 to 3 drops of water on the sample of copper sulfate that is obtained after heating, and we need to observe the thing which is going on. Do we like, is there any blue color copper sulfate is restored? We need to check that. So copper sulfate crystals which seem to be dry contain, so if it is dry, it contains water of crystallization. So when we heat the crystals, what happens? This water is going to remove and the salt turns white. If we moisten that crystals again with water, so we will find out that blue color of the crystal reappears. Okay, so water of crystallization is the fixed number of water molecules that is present in one formula unit of a salt. So 5 water molecules are present in one sulfate is CuSO4 5H2O. Now we would be able to answer this question. So whether the molecule of Na2CO3.10H2O is a wet. So one other salt is which possesses water of crystallization is a gypsum. Okay, it has 2 water molecules as water of crystallization. It has a chemical formula that is CaSO4.2H2O. Okay, and we will look into the uses of these salts. That is plaster of Paris. On heating gypsum at 373 Kelvin, so degree Celsius is converted to Kelvin here, it loses water molecules. So when we heat up to 373 Kelvin, what happens? It loses water molecules and becomes calcium sulfate hemihydrate, that is CaSO4.off, that is 1/2 H2O. So this is called as plaster of Paris, and we know the use of plaster of Paris, POP. Okay, so the substance which doctors use as a plaster for supporting fractured bones in the right position. Okay, so when we get a fracture in our hand or legs, they use POP, right? So plaster of Paris is a white powder, and on mixing with water it changes to gypsum, once again giving a hard solid mass. I think you people have come across the fractures and this POP when you consult a doctor, right? So this is about plaster of Paris and the experiment, that is crystals of salts really dry. Fine children, so here we have completed with the chapter acid, bases and salts. I hope you people have understood the concept. If there's any doubt, we will discuss in the live session. And also you people can come up with the applications of baking soda, washing soda, bleaching powder and also plaster of Paris. Okay, we shall discuss in the live session a lot about it. Okay, so worksheet will be sent along with this video. Do solve it and have a good day.